All right, so we're going to continue on with 4.1, and this time instead of graphing polynomials, we're going to write our polynomials. So in number 1, it says write an equation in standard form of the polynomial with the given roots, -5, -5, and 1. So just like when we were graphing them, right, if I had x plus 1, if I set that equal to 0, I would subtract the 1 over and I would get -1. So essentially what happened is I had the negative, right? If this was positive, then this was negative because I'm subtracting it over. So if I have a positive 1, then in my parentheses I'm going to have x minus 1. And if I have a -5, then in my parentheses I'm going to have x plus 5. And I have 2 of those, so I've got squared. So my equation is y equals x minus 1 times x plus 5 squared. Now, if it said to write this in factored form, we would be done, we would circle it. Okay, sorry, I got a phone call. But anyways, if it said factored form, we would circle this and we would be done. But this is standard form. It's asking for standard form, which means we're going to have to multiply this out. So we've got x minus 1 times x plus 5 times x plus 5. Doesn't matter what order you multiply these out in. I'm going to start with multiplying out the x plus 5 times the x plus 5. So I've got x times x, x squared, x times 5, 5x, 5x, 25. Combine your like terms. And then multiply out again. So x times x squared and then combine your like terms. So we have x to the third plus 9x squared plus 15x minus 25. Now this will give you pretty good credit, but this will not give you full credit, because we cannot forget about our y equals. Okay, I will take off a half a point if you forget y equals. So please do not forget to write the y equals in the front. Okay. All right, moving on. So example 2 here, we've got zeros of the function h, -2 with multiplicity 2, and then 2/5 with multiplicity of 1. So we've got y equals x plus 5 with a multiplicity of 2. And then we've got 2/5 with a multiplicity of 1. So let's think about this. If I had a 0 of 2/5 and I wanted to undo this solving, I would first multiply by 5 on each side and I would get 5x. And then I would have to subtract the 2 over and I would get 5x minus 2. So that's our factor, 5x minus 2. Okay, so the 5 moves to the front, the 2 is in the back, and instead of a positive, it's a negative. The multiplicity is 1, so we have no exponent. Once again, it wants it in standard form, so we're going to have to multiply this out. So x plus 5 squared, we actually just did that in the last example, and got x squared plus 10x plus 25. Now let's distribute out with the 5x minus 2. And it does say that this is the function h, so h of x is equal to. Now, if you guys just put y equals, I would still give you credit for that. I'm not super picky, but if we're being technical, it does tell us the function is h. So we have h of x. Number 3, we have zeros of 0, 0, 2, and 3. So if we have zeros of 0, then that means our factor is x, and we have 2 of them, so that would be x squared. Then we've got 2, so x minus 2, and 3, so x minus 3. This is a function f. And it does say factored form, so I do not have to multiply it out. Please, 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 on your quiz, your test, your homework, always look at what form it is. Okay? If it says factored form, do not waste your precious time on a test distributing this out. Okay, I'm also going to take off a point if it says factored form and you multiply it out. Okay, you need to pay attention to directions. Factored form, they are in factors. Standard form, multiply it out. Okay. Okay, we're going to do example 4, and then I'm going to let you try example 5 on your own. So example 4 says that we have 3x intercepts of -2, 0, and 2. So if I was going to write our function here, we've got a 0 of -2, so plus 2, a 0 of 0, so that means x, and a 0 of +2, so x minus 2. And we also want it to contain this point -1, 6. So what that's saying is all of these so far we haven't been given that. So technically speaking, I could have something that goes through all of these zeros. I'll give you an example. Goes through 0, 2, and 3, and maybe looks like this. I could have one that also looks like this, that goes 0 through 0, 2, and 3. Right? So we don't know what the A term is. It doesn't really matter. This is still going to have these zeros, and we're not saying we want it to be very specific. This problem is saying there's only one function that goes through this point and has these zeros. I want it to be super specific. So this is kind of broad. This is specific. I want to know which of these two, or whatever it is, gives us this point -1, 6. So essentially what I'm saying is I need to find this number in the front. The way we're going to do that is we're going to use these ordered pair where x is -1 and y is 6. So for the y, I'm going to put 6. The a I don't know. X is -1. X is -1. Well, now all I have left is my variable a, so I'm going to use my algebra skills to solve for a. So I've got a times -1 times +1 times -3. Gives me -1 times -3 would be +3a. Divide by 3. A is 2. So my function is, my very specific function is 2x, x plus 2, x minus 2. Now this would be considered factored form. We would circle it, we would be done, but it does say standard form, which means we need to multiply it out. So I like to leave the 2 for later. I personally feel like it's easier to multiply these out and then distribute in the number. So I've got x times x. Middle terms cancel out. Distribute the 2x. There's no like terms. Our final answer, don't forget the y. Okay, I want you to pause, try example 5, unpause, and check your work. All right, so we had a 0 of -1, a 0 of +3, and then a 0 of 0 with a multiplicity of 2, so x squared. We want to find a because they gave us this ordered pair. Plugged in our y, plugged in the x. I got a is -2. Plugged that in for a. It did say factored form, so we did not have to distribute it out, and we're done.